Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Muhammad Najmi Zikri bin Nazri. So for this video, I will present about assignment 2, which is recycle metal classified by using convolution neural network CNN. So next we go to introduction. So nowadays, information landscape problem have the increase and didn't decrease to the waste of recycle. Yeah, one of the possible reasons to this lack of the effort to categorize the waste into the designated category, which are can and plastic bottles. The aim of the essay assignment to pre-arrange design of CNN model to train the data without overrifting or underrifting. For every process, analyze the performance to detect PET bottle aluminum detection material classification. So we go through to the theoretical review. So basically for this task, we are use the Google Colab. So Google Colab is in AI analysis very aggressive. The Google are developing an AI system called the TensorFlow over several years, and the development platform called the Colaboratory. TensorFlow is open source today, and Google has made the collaborative free for the public since 2017. The laboratory is now referred to the Google Colab or just Colab. They use a GPU and another appearing feature to provide to developer by Google. GPU support the provided by Colab is totally free. So we go to the CNN, which is a convolutional neural network. So CNN is a unique type of a multi-layer neural network instead of the immediately identified visual pattern from the pixel picture with a minimal pre-processing by CNN. The biggest data like ImageNet, they can be used to train an entire network from the scratch. Convolutional network work by moving a small filter across the input image, be it the filter are reuse a recognized pattern throughout the entire input image. This make the convolution network much a powerful and fully connected network with the same number of variables. So next is a VGG neural network. This network is diffused by the its simplicity, utilizing only 3 to 3 convolution layers stacked in increased depth on the top of each other. The volume size reduction is handled by the max pooling neural network of a VGG, while the previous AlexNet derivative concept a smaller window size and the step in the first convolution layer, another very significant aspect of CNN addressed by VGG.
In this method, we use the Google Colab as our platform to get the image processing. The method that we use in this program is using CNN and also VGG. So the CNN, or known as Convolutional Neural Network, is a class of a deep neural network most commonly applied to analyze visual image. They are also known as shifting invariant or space invariant artificial neural network based on their share weight architect and the translation invariant characteristic. So both of these method is using coding method to get the analyze visual image. For the task one, the method that we use is using CNN. So for the CNN, firstly we need to start the Google Colab. After that, we define the program, and then we input the design for CNN method. After that, we training using the dataset image, and after that testing of the dataset image, and then the output will be A. So the image of A is defined, will be defined the program. After that, for the run, will set if it achieve the highest validation performance, either is not or yes. If yes, if not, and then it will goes back to the design CNN, and repeat the process until achieve the yes high performance validation. If achieve the high validation performance, and then the system will be end. For the task 2, actually has the same with the task 1. The different for the task 2 is we doesn't use design CNN. We change to the design VGG to get uh, the graph to show the highest validation performance of the method. So the method is same like the CNN. So if the process start, and then define the program, and then design VGG and take data set and process until achieve the highest validation performance. If the performance has achieved the highest validation performance, and then the system will be stopped. If not, and then the system will be back to the design VGG and repeat the process until achieve the highest validation performance. That's how the methodology used to solve the problem using Google Colab.
Hello, my name is Shazwan bin Raza. I will present about the result and analysis. Okay, for the task 1, the result is the accuracy we get after training the pre-trained module is 50%. This shows it is not accurate because it consists more of error during the training process. Okay, the step per report need to be reduced because of the run out of data to be run. As you can see, the process of the testing as the picture shown. Okay, for the task 2, the accuracy of the pre-trained model with the VGG is 99.1%. This shows it has a better result than the pre-trained model without the VGG. This is because it has less error during the training process, and the validation step is 2, as you can see at the picture. That is all from me. Thank you. Session, we are going to use the Google Colab. Okay, first of all, for us to manage the project, we need to mount our drive to the Google Colab. Okay, this is the coding for to mount our Google Drive to the Google Colab, and then we are going to import our file for the data set. As you can see here, we need to import the OS, and this is the coding to recall our path file. And then after that, we need to import the library that is going to be used in our training session. Okay, all of this is our library that are going to be used in the project. And then we are declaring our path file for the image that is for the train, the can train dir, pet train dir, the validation dir, can validation dir, pet validation dir, and our test dir. Okay, here is the path file to our Google Drive. Okay, and then we are going to recall the class preprocessing image from the class library, and we are going to import the image data generator. Okay, so now we are going to do the pre-processing, data pre-processing. So this is the code that are going to use for the train data gen, the validation data gen, the train generator, val generator. Okay, so here we can if we use categorical, we may have many files. If we want to use, we have two files, we can also use binary. Okay, so here you can see it has found 466 image belong to two classes and 210 image belonging to two classes. Okay, then we are going to show our picture by using the import matplot library, so it can plot our picture and divide it within its classes of can or pet. Okay, so you can see the data here already been divided to can and pet, as you can see here. And then after that, we are going to do the CNN model architecture. Okay, so here is the CNN model architecture. And then we are going to do our what we call the plot our model. So here's our model, the convolution, input layer, convolution 2D, max pooling, convolution 2D, max pooling 2D, dropout, flatten, dense, dropout and dense again. So this is our model summary. This is our total parameters and this is our trainable parameters. And then we are going to call our TensorFlow file for optimizer. Okay, this is to train our data gen and our test data gen. Okay, so here we get 466 image belonging to two classes and 210 image belonging to classes, and the data batch shape is 20, 150, 150, and 3. The label batch shape is 20. Okay, now we are going to train our model. So to train our model, we are going to put this code history equal to model.fit underscore generator, and our step per epoch is 10, our epoch is 30, our validation step is 2. Okay, so this is our result. As you can see, our result is the accuracy is 0.5. Okay, validation accuracy is 0.5. Okay, and then we are going to save the model to use it to train our new data to test our model if it is accurate. Okay, and then we plot our model M1 graph of accuracy and our graph of losses. Okay, so here you can see, here you can see our training and validation accuracy and our training and validation loss. Okay, and then after we are going to test our training model M1 with a new data set. Okay, so this is we are calling our model dot equal to tf class models dot load underscore model. This is to call our model back. Okay, and then this is our model summary, is to test our new data set to be used to test our model M1. So it found 3 images belong to 1 classes, and then we test the model and we found that the accuracy is 0, 0, and it is not accurate because it has many losses and errors during the testing. First of all, the step is the same. We need to mount our Google Drive, and then we import the OS and give the path file, the path file that is for the directory of our dataset, and then we create train and validation directory. Okay, so that we can fetch data. from our file that is on the Google Drive. And then, as you can see here, we can find the can trend length is 126, pet trend length 210, can validation length 77, pet validation length 103, and then the can and pet test length is 1. Okay, and then we import our library that are going to be used, and then we are going to do the CNN architecture. Here you can see getting the CNN architecture, and then this is the summary of the CNN architecture, the total parameters, trainable parameters, and the non-trainable parameters. And then after that, we pre-train the module with the VGG. Here is the code, and here is the summary of the pre-train with VGG. Okay, as you can see here, the total parameters, the trainable parameters, and the non-trainable parameters. And then we are going to flatten and dense our pre-trained model with VGG. So after we do that, we can get the total parameters and the trainable parameters and the non-trainable parameters. As you see before, the trainable parameters before is 0. Now it has a value. And then we are going to pre-process our data. Okay, here is the pre-process of our data. So here you can see after running the code, we found 466 images belonging to 2 classes, found 210 images belonging to 2 classes, found 3 images belonging to 1 classes. Okay, for your information, the first one here belong to the training classes, the training file in our Google directory, and the second one here is from the validation directory, and the third one here is from the testing directory. Okay, after that, we are going to test our pre-trained model with VGG. Okay, our step per epoch is 10, our epoch is 10, and our validation step is 2. Okay, here we get the value accuracy is 99.2. And then after that, we are going to save our module so we can recall it when we are testing the model with a new data set or new image. Okay, then we plot the accuracy of our model M1. Okay, so here is the accuracy, the training and validation accuracy, and I'm sorry for this, the training and validation loss, not accuracy. And then we are going to recall our model M1 to be used for testing with new dataset of image. Then here is the testing process for the new dataset of image, and we get the value accuracy is 1.0. So it is better than without using the VGG. That is all. Thank you.
So, for conclusion and recommendation, for the conclusion for the task given, we managed to fulfill the task 1. We use the CNN model trained to image analyze the performance. We implement the task by using the Google Colab from the Spider Python to train the image by given. But in the project, we lead to on the new software, and we have again a new knowledge is a term or achieved by the objective in the project. From training progress result, we have received by the using the Google Colab method, the accuracy of the convolutional neural network of all the images are given not a very accurate. For the task 1, the accuracy of the hair from training equal to 50%. This shows the CNN model having a low accuracy to detect the image. For example, in this experiment, we are using several picture pet and can detect the image from the model M1. For the second task, the progress are also similar to the task 1, but we use a different model. The model we use is a VGG Neural Network, and the accuracy are better than the CNN. This show the result of the task 2 is the accuracy of the pioneer model with the VGG is 99.1%. This show they have the better result than without the VGG. This is because it has a less error during the training process. For the further recommendation, in the model M1 are need to more picture. This because they have the more picture, the system can give a more accurate result from the train that we have. So this end of this video. That's all from us. Thank you.